Ma'am, we can start, ma'am, preliminary. Then I will proceed with Muttan sir.
Okay. I'll just start with the introduction and then you can correspondingly follow.
Okay, ma'am.
So I'll just introduce welcome to all the participants. Welcome to our esteemed speaker, Professor Muttan, for the day, who has given us the consent for initiating our faculty development program on leveraging healthcare, innovations, technology, and applications. So we'll be starting from 16th December 2024 till 21st of December 2024. So what the main motive of our particular FDP is, it's leveraging healthcare, innovations, technology, and applications. So we thought of giving a short form to it as HealthITA. So it is the impetus behind transforming business processes into the health sector of the economy. One of the main reasons for this growing area is the rapid advancement into the census technology. So even advancement into the automation technology, intelligent systems, the machine learning, the vision-based surveillance systems, robotics, autonomous systems, advanced networking, image processing. So we thought of that we should take this particular step forward in bringing all these technologies and how our healthcare arena can be benefited through that. So we initiated this particular FDP with that particular aim. So now I'll just like to brief up about AICT and ATAL. So AICT, the full form is All India Council for Technical Education. As all of us are already aware that it was started in November 1945 as a national level apex advisory board to conduct a survey on the facilities available for technical education and to promote development in the country in a coordinated and integrated manner. So first AICT training and learning, that is referred to as ATAL Academic, and NWRO in Jaipur was announced with the establishment of other ATAL Academy in the country at Jaipur, Vadodara, Guwahati and Trivandrum by the Honorable Union Minister, Human Resource Development on 24th 9th 2018. The main objective of ATAL is to plan and help in imparting quality technical education in the country and to support technical institutions in fostering research, innovation, and entrepreneurship through training in various emerging areas. Now, I would like to give a simple glance about National Institute of Technology, Delhi. So we have Department of Computer Science and Department of Electronics and Communication Engineering in collaboration. We initiated this particular FTP. So NITD is one of the 30 NITs established in the year 2010 by an act of parliament and has been declared as an institute of national importance. NIT Delhi is an autonomous institution which works under the aegis of Ministry of Education, India. It aims to provide instructions and research facilities in various disciplines of engineering, science and technology, management, social sciences, etc. The mission of NIT Delhi is to produce human resource, those who are creative, competitive, and innovative with high intellect and ethical values. The institute is imparting holistic education along with inculcating high moral values in its student. So me, along with my co-coordinator, Dr. D. Vaithiyanathan from Department of EC and NIT Delhi, would like to welcome you all to this particular FTP. So we'll be having 13 sessions for the particular FTP, where we'll be starting from the first session from 6 to 7:30 onwards, and the second session will be 7:30 to 9 o'clock. So we'll be taking attendance during both the sessions. So one of the attendance we'll be taking at 6:45 and another attendance will be taking at 8:45. So these two are the timings through which I request all the participants to kindly turn on their camera and please so that we can take a attendance corresponding to that. And also as per the norms being floated by the ATAL, we will be conducting a test at the end of the particular FTP. So one thing will be the feedback that will be form will be shared and you have to fill in the feedback, and the second part is the test that will be conducted on the last day of the FDP, that is 21st of December. So in the in the particular examination, you'll be giving some 25 multiple objective questions. So you just have to attempt those questions, and then you have to score a minimum of 75% marks in that, and an attendance of 80% is mandatory if in case you want the certificate from AICT ATAL to be delivered to you. So once we'll upload all the things onto the portal, then only the ATAL will approve it, and correspondingly you will be able to download the certificate. So this will take another, I guess, 15 to 20 days or whatsoever the ATAL will be taking. So we'll be doing it in the next week after collecting all the data, and then correspondingly ATAL will be approving it. Finally, you will be able to download your certificates. Now I'd like to hand over the mic to my co-coordinator, Dr. T. Vaithiyanathan. Over to you, sir.
Thank you, ma'am. Thank you. Good evening to all. Yes, sir. First of all, I like to thank the coordinator for giving me these opportunities, and also about our director, Professor Ajay Keshavma, and then all the ACT team to consider us and approved for this FDP. Okay. And before going to start, I like to thank all the participants. Please, sir, everyone mute your camera as well as mic. When we are saying, at the time, you can unmute your camera and mic. Okay, sir, if needed. Okay. So first of all, I like to thank all the participants registered for this program. So at most 100 plus participants registered for this program. And of course, there are many experts going to deliver their lecture during this 6-day program from today onwards to 21st December from throughout India as well as from abroad. Okay, this is first I like to thank, and really it's my pleasure to introduce my professor, Dr. S. Muttan. Sir, welcome, sir. Welcome you.
Good evening to all of you.
Yes, sir. Thank you, sir. I'll just introduce yours, and then you can start your session, sir. Yes. Oh, first, okay. First of all, I know Dr. Muttan, sir, from, if my memory is correct, last week of November 2010. That is, I attended the interview, teaching fellow in CG, Department of EC, CG campus. There, he was one of the panel member, along with Professor Ramana Rao and Professor Kumar. If my memory is correct, it is the December 2nd, actually. Okay. From there onwards, our journey starts. Okay. So first, I like to thank the Muttan, sir. Dr. Muttan, currently a professor of Eminence, Center for Medical Electronics, Department of EC, College of Engineering, Gindi, University, Chennai. Dr. S. Muttan, professor of Eminence at Center for Medical Electronics and
Sir, your mic is unmuted, sir. Yeah. Audio is not. Vaithiyanathan.
Yes, sir. Yes, sir. From back.
Please.
So now only.
Yeah. Fine.
Okay. Sorry, sir. Okay, I'll repeat something. Okay. So Professor Muttan, sir, holding the various positions as a director in charge of IIIT Srirangam and Bharati Institute of Technology, Tiruchirappalli, additional director, Constant College, former director, Center for Medical Electronics, director, Center for Medical Electronics, and deputy director, Center for Affiliation, deputy director, Anna University Sports Board, deputy register, finance and personnel, and finance officer in charge of Anna University Chennai, and Green Gindi officer. He also held the position of chairman, NBA Working Committee of Anna University Chennai, overseeing the process of aiming NBA culture at all levels and towards aggregation, and currently involved in its automations. Yes, Dr. S. Muttan has undergone training in the area biomedical engineering in Germany, was a visiting professor for the Dhaka University, Bangladesh, and had research collaboration with the University of Westminster, London under UP stream. Dr. S. Muttan was instrumental in the starting an undergraduate program in biomedical engineering and 2 postgraduate programs, namely ME in medical electronics and ME in biomedical engineering in the Department of Electronics and Communication Engineering, College of Engineering, Guindy, Anna University. Further, he was a member of Academic Council and Board of Studies of many universities and institutions across India. He was also nominated by the government of Tamil Nadu to be a member of Planning Board of Tamil Nadu Open University and into Academic Council of Anna University. He also nominated as a member Board of Governors for Indian Institute of Information Technology, Srirangam, by the government of Tamil Nadu. Dr. S. Muttan was the coordinator, National Hub for Health Care Information and Development, NHID, a unique hub with the support from the DST, Government of India, dedicated to the design and development of indigenous medical devices in India, collaborating with the IIC, IITs, universities, reputed national research labs, industries, and hospitals. 15 healthcare products have been developed by the NHID during a period of 10 years with almost all of them over and above TRL level, that is a project transform level, and have been technology transferred to the industries. Anna University has the distinguished of being awarded the coveted status of university with the potential for excellence in biomedical engineering and instrumentation, UPE, by UGC, among all the Indian universities with an allocation of 27 crores. Professor S. Muttan was chosen to lead this prestigious scheme in the capacity of coordinator under UP scheme, national platform in cutting edge technologies such as bioscience, optoelectronics, medical imaging, limited manufacturing in mechanical, and electronic system design and instrumentation were established, with which together can make an industry-ready commercial healthcare device from concept to commercial forerunner for Make in India concept. Under the aegis of NHID and UPE, many medical gadgets were designed, developed, fabricated, manufactured with the limited manufacturing capability available at Anna University and commercially with the successful technology transfer of 2 industries. Unique semi-automated devices capable of identifying the right antibiotic in the case of urinary tract infection within 6 hours as against 24 hours was designed, developed, manufactured, and quality tested fully in-house with limited manufacturing state-of-art facility established in the areas of optoelectronics, mechanical, and electronics PCB design through UPE funding by UGC. Technical, competent, and commercially viable gadgets was developed indigenously by a multidisciplinary team headed by Dr. S. Muttan as a principal investigator, and a patent in this regard was granted under his leadership. This innovative medical device was developed based on the patent scientific principle invented by the Department of Biotechnology, Anna University, Chennai. Dr. S. Muttan has had taken keen interest and initiated many programs which created a lot of awareness among all the stakeholders of medical devices, testing and calibrations. He was instrumental in the establishment of Center for Calibration of Critical Care Equipments and that spearheaded the testing and certifying of more than 15,000 medical gadgets in 311 hospitals across India, garnering consultancy charges close to 90 lakhs. In addition, he is ISO 17025 to 2017 auditor, having expertise in medical device regulation and a member of National Federation of Engineering for Electrical Safety. under that is your United Kingdom India Education and Research Initiative in collaboration with the Leicester University as a academic partner and company, the Appasamy Associate Chennai, a pioneer in ophthalmic instruments. Professor Muttan sir has successfully developed a MOPscope, a portable microscope attached to a mobile phone, which could be used to identify malarial parasites from the blood samples, and published a patent in this regard. He has been the principal investigator in many funded projects, namely wireless sensor networks applied to telemedicine, design and development of web-based online telehealth consultancy systems.
Vaithiyanathan.
Yes, sir. Yes, Professor. Yes, Professor.
Yeah, I think you can go to the next.
Fine. Okay, fine. So there is a lot of things. Actually, I can go ahead with the Professor Muttan. Actually, I am very fortunate. I can associate with the professor for the last 15 years. And of course, he was my HOD, and I was worked with him for nearly 7 years, okay, in the same department. I know actually all things are coming into my memory. Sir, I really thank and welcoming you to this and handovering this to you, sir. Over to you, sir. Thank you.
Yeah, thank you. Am I audible?
Yes, Professor. Yes, Professor.
Thank you. Thank you. At the outset, I would like to thank Director Ajay K. Sharma, NIT Delhi, Dr. Shelly Sachdeva, coordinator of this wonderful program, Dr. D. Vaithiyanathan, the co-coordinator. The topic has been very attractive. Leveraging healthcare, innovation, technology, and applications, very apt today. I think after many hundreds of years, the last 10, 15 years, India has really taken a turn towards betterment. And it is the right time that all of us should put all our effort to see that we grow well. I think I can begin my lecture. I'll go to share. Please check whether the slides are visible. Kindly help me. Is the screen visible?
Yes, Professor.
Yes, sir, it is visible.
Thank you. Then I'll go to slideshow. Okay, fine.
Yes, sir. Yes.
Thank you. In fact, I took my undergraduate from SV University, Tirupati, and I did my PG course, and then I became a faculty at the College of Engineering, Guindy. I'm proud to be a faculty from Anna University, College of Engineering, Guindy, which has 230 years old, for your kind information. And the Department of EC, which I belong, is the first in the whole of our country to start telecommunications in the year way back in 1947. And here you can see the 1948 batch, the first women electronics engineer you can see here. The topic is, as I said, very enchanting. Faculty development program on leveraging healthcare, innovation, technology, and applications. I think, as Madam Shelly has said, there are 30 plus lectures awaiting all of you. And in fact, the next 5 or 6 days. And that too, what I'm very happy about this program is there are 3 important duties of a student or a teacher. The first duty is to study. The second duty is also to study. The third duty is also to study. This is what a Russian proverb goes. Therefore, it's wonderful that such a concept of, in fact, taking up FDP at 6 o'clock is really appreciative. I think we are faculty members ready to take up learning 24/7. Therefore, sitting at 6 o'clock, listening up to 9 o'clock doesn't matter for all of us. whether it is for me or whether it's for you, we would like to be part of this wonderful learning and teaching and learning processes. I hope always I enjoy my teaching. And similarly, I hope that you also relax and try to listen. Let me put things very straight. You have many businesses in the world. But the biggest or the mother of all business is the healthcare business. Because everybody do not have the car. Everybody cannot have own house. Everybody cannot have everything. But everybody will have to be a patient one day or the other. Therefore, everybody has to go to the healthcare system. That's why this particular field is called mother of all businesses. So in this mother of all business, there are three important industrial pillars, namely radiology, pharmacology, and e-health. Almost 33% to 35% of the business turnover in this mother of all businesses comes from health informatics. So rightly, I thank Dr. Shelly, Sachdeva, and Vaithiyanathan. Really, they have taken up a very hot topic, which is very, very important today for India, because India is moving towards digital health. So in this aspect, I think NIT has really taken up. I congratulate the management for giving such a wonderful permission and the AICTE for encouraging such a FDP to be organized by NIT Delhi. So pharmacology, yes, no doubt, we are competing best in the world. Radiology, yes, no doubt, we have excellent people to interpret and provide diagnosis. But somehow in e-health, we really are lagging behind. So I think many such FDP has to come, and all my dear participants, you have to take up this challenge, because it is this health informatics which is very important for the growth of India. This e-health, call it as e-health, or call it as health informatics, or call it as digital health, but it is going to rule, and let us get ready for the future. The first question is informatics. All of us are from information technology field. So basically, we should know what is the definition of informatics. It's a beautiful definition by Van Bemmel. It comprises that is, the definition of informatics goes like this: comprises the theoretical and practical aspects of information, which means every information can be taught as in two dimensions: practical information and theoretical information. So informatics comprises the theoretical and practical aspects of information processing and communication based on knowledge and experience. So which means informatics is about information, but this information has to come from somewhere. There has to be some source. This source is nothing but it can be a theoretical source or it can be a practical source. So whatever information you collect from a theoretical source or a practical course is the input for this informatics. And you are not just happy with these two acquisition. Next is important thing. What are you going to do with this information? Then you have to process it. It's a huge area. A lot of algorithms are there. I think you're all from computer science and information technology. It's mind-boggling. Algorithms are available in the whole of the world. Therefore, processing is a big area. And then communication through the network. So acquire the data, acquire information theoretically, practically, process it, and communicate it through networks. But however, there is a rider. Whatever information you collect has to be from a knowledgeable and experienced source. Always, my dear friends, you agree with me that if at all you would like to visit a doctor, you will always ask whether the doctor is experienced. You will never go to your doctor who is just has completed his MBBS degree just yesterday. Always you look for experience. Always you look for a brand name. Always you look for a education system which is like NIT, IITs, and one of the best universities in the world, because we want great people to teach us. We want experienced people to interact with us. So experience and knowledge is fundamental. Therefore, theoretical information, practical information from the mouth of a knowledgeable person has to be processed, communicated, and some decision has to be taken. This is exactly what is the backbone of informatics. And if this informatics is in the health, derived from health, then it's called health informatics. So health informatics comprises of theoretical and practical aspects of information processing and communication from knowledge and experience derived in the field of health, then it becomes health informatics. If it is derived in the medical field, it's called medical informatics. If it's derived from nursing, it's called nursing informatics, medical informatics, bioinformatics, clinical informatics, consumer informatics, imaging informatics. I think the world is very big for informatics. So this is the beautiful definition. And this information is also called a grid. Look at the definition of health grid. Health grid is nothing but a combination of two words called health and grid. And this is the grid is a very common word in electrical engineering. We have south grid, northern grid, because that is a source. It's a, area where you store a lot of energy. Similarly, health grid is nothing but all levels of data and information from molecule to population. What a beautiful definition you can watch. Health doesn't mean concerns only you and me. It concerns everybody on the earth, including every molecule. So that is the universally divine definition of health. Health kindly don't restrict to only you and me. It doesn't focus only on human beings. It focuses on every life on earth. So health, the definition of health goes like this. All levels of data and information from molecule to population needed to ensure better prevention, diagnosis, and treatment is the definition of health. Grid is nothing but an environment created through the sharing of resources in which heterogeneous and dispersed data as well as applications can be accessed by different partners across their based on their authorization without loss of information. This is the definition of health grid. And this is in a nutshell to make you comfortable with the definition of informatics. Health informatics is a combination of healthcare, computer science, and information technology. And if you go a little deeper again, many people are not still aware. There are a lot of differences between the term medical informatics, bioinformatics, neuroinformatics, etc. Medical informatics and bioinformatics are totally 180 degrees out of phase. See, medical informatics is an area where the ICT application, information communication technology applications are applied to a level of the man, mass, population, citizen, patient, and population informatics. Whereas bioinformatics is application of ICT to a molecular informatics, on molecule. Therefore, kindly be very clear that bioinformatics and medical informatics are totally different. Medical informatics is concerning with hospitals, bioinformatics is concerned with the lab, drug design, toxicology, so many. So it goes with more with science, whereas medical informatics goes with technology. Medical informatics is like electronic health record, health informatics, clinical decision support, intelligent agent, telemedicine, network, all those things will come under medical informatics. Whereas if you look at bioinformatics, structural genomics, functional genomics, proteomics, biochips, MEMS, a lot of things will come under that. And the third one is there called neuroinformatics, which talks about processing, biosignal processing, pattern recognition, fuzzy logic, human computer interface, body area networks. I think this is the area which is called cell to organ informatics. So this term health informatics encompasses all the three, and the synergy is created. So health informatics is a synergy among medical informatics, bioinformatics, and neuroinformatics. And my dear friends, it doesn't stop there. And a combination of these three is what we call as personalized e-health. Every individual will be focused in future. It will not be a population study. Every individual will be given a separate diagnosis and therapy. If you look at health informatics, it's bioinformatics, clinical informatics, imaging informatics, patient record, and I can see these are the subdomains of health informatics. Clinical informatics, medical informatics, nursing informatics, public health informatics, bioinformatics, imaging informatics, pharmacy informatics, dental informatics, veterinary informatics, consumer informatics, e-health informatics, clinical and research informatics, translation research informatics. I think the big list is big. You kindly add as many as you want. All of them put together is what is called health informatics. So I think, again, let me congratulate congratulate NIT team for taking up such a wonderful topic. But what my worry is that still people have not realized the potential of this health informatics. I think it will compass all of us. Without this health informatics, there will be no future for India. And everybody is a stakeholder, as I said, because everybody is a patient, but everybody is not rich, everybody is not poor, everybody doesn't have everything, but everybody will have some disease or the other. Therefore, every one of us are stakeholders in this health informatics. health professionals, doctors, nurses, allied professionals, administrators, researchers, pharmacists, and so on and so forth. And patient. Obviously, patient is the core of the healthcare, which means the 7.5, 8 billion people are the core, the whole population of the world. And I'm sorry, I should not only consider human beings is for everybody on the earth, molecule to mass, molecule to population. And let me just brief you about medical informatics. Medical informatics, yes, same definition of informatics, comprises the theoretical and practical aspects of information processing and communication based on knowledge and experience derived from the field of medicine. It's called medical informatics, defined by Van Member. It's one of the beautiful definitions. I have gone through a lot of definitions in medical informatics, but this one is a very wonderful definition and very close to my heart. The structure of medical informatics and methods information is taken from the book, and Van Bemmel is a great man. And the beauty of this definition is that he also classifies medical informatics and placed the medical informatics in 6 levels of complexities. See, communication and telematics, storage and retrieval, processing and communication, diagnosis and decision, therapy and control, research and development, which means any process that happens in healthcare area will begin with the data collection. Correct? Data collection. Then once you collect the data through varieties of means, varieties of modalities, next problem is how do you store? Hundreds of algorithms are available. You have to decompress, you have to decompress, you have to encode, you have to decode. A lot of things are there, and you have a lot of formats also. You have MPEG format, JPEG format, .dat format, DICOM format. How many formats are there? So all these things will come, and also how to retrieve. So that's a second challenge in medical informatics, and this was good for any informatics for that matter. So collection of data, ECG, PCG, EMG, EOG, and all your non-electrical signals, temperature, pressure, and all your, imaging modalities, whatnot. All of them will come in the first layer. The second layer is how are you going to store them? What standards you are going to follow while storing them? How do you retrieve them? How do you store? Because the biggest data analytics is healthcare. As I told, the mother of all business is healthcare. Similarly, the big data analysis, the biggest data analysis is only from healthcare. I just say with a lot of confidence. So once you have all technologies, applications, this is what leveraging healthcare at the level of acquisition, at the level of storage, at the level of retrieval, and at the level of processing, at the level of automation. So once the first 3 levels are over, next is the biggest problem, like diagnosis. How do you diagnose? Pattern recognition, artificial intelligence, AI, deep learning, and whatnot, machine learning, fuzzy logic, genetic algorithms. A lot of things are there. Neural networks, artificial neural networks, CNN, ANN, whatnot. So it's a big bouquet of decision-making algorithms are available to take care of diagnosis and then decision-making, CDS, clinical decision-making systems are made up, and thereby it leads to excellent healthcare expert systems can be generated. And once that is first, it's like going to a doctor. Doctor collects the data, stores the data, interprets the data, retrieves the data, processes it, automizes it, diagnoses the problem, and may finally gives the decision making in the form of therapy. That's the 5th level. Therapy and control, feedback. And after this, and in fact, what I would like to impress upon all of you is that as far as our country is concerned, unfortunately, our medical fraternity are working only up to a level of 5, which means they're excellent. The world beaters, in fact, no doubt about it. Every doctor in our country is a world beater. He does such a wonderful job. But unfortunately, because of our population, they are bogged down with only servicing, and they are not going to the next level called research and development. Whereas in other countries, advanced countries, most of the doctors, in addition to meeting the requirements of level 1, 2, 3, and 5, they also focus on level 6, which is research and development. That is why a lot of things are happening in advanced countries than what is happening in India. So this barrier has to be broken. This cultural barrier, financial barrier has to be broken in India. So that is the levels of complexities that is available in medical informatics. And whatever I said now, in the next few slides, I will not explain. I'll go through. See, first level is collection. Yeah, you have the sensors, you have diagnostic, therapeutic nanobots, biobims, bionems, implants, okay, Internet of Things, 5G network, everything comes in the level 1. You can see some of the examples, ECG through wristwatch on a chair, sleeping disorders. I think these are all collection of data, level 1. Then smart floor. Yeah, once you fall, signal will go to the caretaker. Nowadays, we are all living in a nuclear family, and we'll be leaving our parents, elders at home. We'll be really worried about them. Suppose if one of them falls in your house, immediately through sensors, through IoT, information will come to us. So the floor are very smart. Toilet is smart because the toilet can sense the blood sugar level. It will inform our own elder people that you have taken more apple juice, and please control your blood sugar. You can see here that you can see there's a sensor to sense your blood sugar. So it's a smart toilet. Medication reminders and wide range of applications. You can see on body, in body, off body, a lot of sensors are there to do all this job. IoT based medical applications, Internet of Things, Internet of Medical Things, meetings, M-Health, and you have a plethora of interfaces, sensing network, IoT cloud, then graphical user interface, mobile apps, then data collection, decision making, then therapy, control, all of them will come here. Wearable devices are coming out. Then every day you can check your body mass index. Yes, full body mass sensor. These are wonderful body area networks. I think such things is very beautifully going on. Thanks for your attention. And this is again going through personalized e-health. See, there is a person sitting in a home. He's interacting with the doctor. But this is not just a video conference. Let me tell you, my dear friends, it's not just a video conference. When the doctor tries to interact with the patient, he's able to see all his data, which means on live, he's able to see the patient history, medications, allergies, lab results, radiology reports, vital signs. Not only that one, again, he can go to the server and check his clinical data for the last year, before year, or similar problem from radiological center, which means almost a live consultation. The doctor will be given everything about the patient because all the data of the patient will be stored in a centralized database server. So once you just come on the screen, the doctor sees you, automatically you are authorizing him to check all your medical data that is stored in a centralized server right from your birth. Unfortunately, that is not available, but I'm assuming that the day I'm born, my data is stored in a centralized database. Now I'm 64. So for the last 64 years, in whatever hospital I have gone, all my data, which is pathological result, biochemical results, radiological results, all my parameters, all the data, whatever I have undergone, my past history, everything, demographic data is stored in the centralized computer. I wish that this is very important, not only for me, for these 8 billion people of this Mother Earth. Yes, we have to have an electronic health record. Just imagine India has a population of 140 crores. Thank God, yes, already above 71 crore people have registered. What if 50% are registered today? Imagine if all the 100%, 140 crore people get registered and all the data is available in the database, centralized database, anywhere, anything can be done. That is the beauty of health informatics. So personalized e-health, seamless access to 7.5 billion electronic medical records of individual across all nations is possible. So data can be collected from home, from school, from clinic, from prison, from company, from battlefield, from research facility, emergency scene, hospital, why not everywhere? So that makes very interesting. And you can see the variety of data, medical multimedia data. That's why it's called informatics. Yeah, PCG is waveform. Then MRI is image. ECG is a signal. So you can see the human body is a source of multimedia clinical data, clinically significant data. So all this data has to be stored in a centralized clinical database. Yeah, you can see now glucometer is there. You can read the glucometer online in non-invasive, and people are slowly moving towards more and more towards non-invasive of data collection, design, develop, deploy a coded, structured, shareable, scalable, distributed clinical database model, smart home care, automation with IoT devices. All these are possible. And this is a structure that I'm trying to imagine for the level 1. So level 1 collection of data has to come from everywhere. That's why IoT is the two important words that all of us should appreciate today is IoT and 5G. Maybe 6G will come tomorrow. These are the two things which are which will make seamless data interface. So IoT, and this is a beautiful structure, smart home, healthcare management and medical sector. Point of care is the word, buzzword. Point of care, wherever you are, you will be just taken care. Cognitive internet medical things, smart healthcare. Okay, IoT framework of heart disease prediction, IoT-based distributed healthcare systems. I think I'm just going through. I'm just telling these words. Just listen them, and whenever you find time, just Google through internet, IoT-based distributed system, IoT framework of heart disease prediction. They're all available. So I need not explain because you're all well qualified. Only thing is you need some introduction. I'm just making you move towards the road. I'm just showing the road. I think you can run, you can jog, and you can enjoy. And interoperability is a very important term because we are thinking of connecting 7.5 billion people across all boundaries, across all cultures. I think it's very difficult. So you have to have a very good interoperability e-health data. So transport of data, information, knowledge over time, space. You can see over time, space, and talk context and community and culture. So health informatics is not that easy as we think, because whatever small data you're trying to transmit has to be interoperably successful. One party has to understand the other party. So the data has to stand transmitted over time, over space, over context, over community, over culture. That is what is e-health. Needs many shared points of reference. Trust is very important. And without standards and standards organization, there are no shared points of reference, because that's why you have a lot of HL7 standard, FIRE, FHIR, DICOM standards, okay, 6601 standards, 17025 standards, 62304 standards, functional safety standards. A lot of things are there in medical data. So that is why the trust comes, because you say that I'm following a standard, standard design protocols as advised by IEEE or as advised by WHO, etc., etc. So trust comes from your capability to, inform people that you are following standards and standards suggested by the standard organization. This is what I like to tell you, healthcare data standards. See, there are 4 areas in the healthcare data standards which are relevant to our health informatics: terminology standards, content standards, transport standards, and privacy and security standards. So terminology standards, you have a SNOMED, which has over 1 lakh vocabulary. 1 lakh vocabulary medical terms are there. They are standardized. ICD-11, International Codification of Diseases. LOINIC, that standard is for laboratory, the clinical laboratories, pathological laboratories. Then you have IRMA for images. They're all terminology standards. So whatever you speak, whatever you tell in a medical setup has to be understood by everybody on earth. It cannot be only for you. You cannot have a code exclusive for you. Therefore, there must be a standard, and these are all standards advocated by world across. Content standards, yes. Again, the content has to follow a standard. And again, you have 3 tiers. You have the database has to be standard. The server has to be standard. The application software has to be standard. Your program has to work in all platforms, platform independent, language independent, whatnot, like that. Then transport standards. So when you want to transfer information from one place to another, HL7 standards, DICOM standard, FIRE standard, they're all important for transportation, because through the network, your data has to go and it has to be understood. And finally, the most important thing is the clinical data, patient data is very fundamental, and the patient data has to be respected. The privacy and security has to be taken care. In USA, they call it as HIPAA. In EU, they call it as GDRR and CCPA in California. So these standards protect the interest of the individual patient. And I have given just a glimpse of how the standards look like. See, you have a repository medical data on the cloud, and you have the hospitals, clinical labs, entities, imaging centers, hospitals, doctors, patient insurance agencies, etc. So we have the cloud here where the data has to flow. So whenever clinical lab, you go visit a clinical lab and a lot of, you give your blood, your urine, a lot of diagnostic clinically significant data is obtained. All this data has to be uploaded onto the repository of medical data following the standards LOINIC, SNOMED, and then FHIF, R4. And if you are from an imaging center, you have to follow DICOM, IRMA, SNOMED, FHIF. If you are from a hospital, yes, all this. If you are even ICD-11, you have to take care. Doctor, yes, these things. Patient and insurance, they take care of HIPAA. They're very serious about this. If you don't follow this standard, you will not be provided insurance. So this is the beauty of integrated scalable database, which means that medical data is alphanumeric, waveforms, images, audio, video, adhering to standards to foster interoperability as per ABDM compliant. That's very important. India has come out with an ABDM body, and all of whatever software we develop has to be in compliance with ABDM. So ABDM suggests that you have to go through all these standards. Therefore, whenever you develop a software in health informatics, please first check what kind of standard you have to go through. So that is one kind of standard. This completely software. This, whatever I have shown here, 95% of them are software standards. This is for hardware. 6601J. Whenever you make a medical device, then people will say, is your medical device in compliance with IEC 66011, which is called gender standard? Is it satisfying collateral standards, which is called IEC 66011, 1XX, see, which means 2 for EM electromagnetic compatibility, 3 stands for X-ray, 6 stands for usability, 8 stands for alarm. That is, whenever you design any medical device with some alarm, then they will say whether we have satisfied 66018. And environmental condition. Yeah, naturally, environment friendly devices has to be developed. And if it is for home care, you develop a medical gadget or even a software. As per the definition of medical device, even software is a medical device for your kind information. So whenever you develop a medical gadget, medical device, which can be either hardware, which can be either hardware or software, and it is for home use, then your standard should be 66011. Then you have pseudo collaterals, IEC 6263, all the software. See, you the previous you're writing, so these are all complete software platform. So whatever software you write, then you have to really get this standard. IEC 62304 is software standard. So you have to get certificate from this agency who will certify your software that you are in compliance with IEC 16. It's nothing but our life cycle of a program. You are very comfortable with the SDLC, we call it as system development life cycle. That is what is IEC 60604, and the usability, because it should be user friendly. Correct. Yeah, you cannot write a software say that only I can use. Everybody has to use, and also every vernacular language. That is, if you are comfortable with Hindi, naturally I have to provide you in Hindi. If you are comfortable with Tamil, I have to provide in Tamil. So usability is very important in any device. So usability is 6236, and also finally, whether it's a software or hardware, risk management. So you have to identify what kind of risks are generated, whether it is a software or hardware. You have to list all the, probability risk that can come out of this software or hardware, then give a solution to that, so that people know that how much your device is safe. So safety and performance is needed. Then if it is in the field of IT and audio, these has to be taken. And this is a particular standard. If it is for high frequency generator, infusion pump, patient monitoring system, then if it is a patient monitoring system, yes, you have to go through this standard. If it is a ventilator, there is another standard. If it's an X-ray machine, there is another standard. So like that it goes. And finally, components, critical standards. So when you design a hardware, you may be using a resistor, you may be using a capacitor, you may be using a PCB. So even when you use a PCB, automatically you have to go through all these standards. If you're using optics, then IEC 60747 standard has to be followed. If you're using a battery, if you say that, sir, I'm trying to come out with a solution with only battery backup, it's standalone system, I don't need 230 volts AC, then in that case, your device has to adhere to this particular standard, secondary battery. So this is a glimpse of the hardware standards. This is a glimpse of software standards. As a faculty, we should appreciate all these things. I have given the roadmap here in the level, TRL level, thanks to M. Pragati. Recently, I have attended 2 days conference in the pre-compliance standard. So this is what, and this is I have prepared anyhow. I have taken this slide from there. So here, if you see carefully, that software standard, I mean, this is TRL level 1. TRL level 1, data, proof of the principle, proof of concept, functional feasibility, preclinical studies, then pilot clinical studies, and pre-commercialization. The 8 levels they are given. And if it's a software, then terminology content, transport content, security content, privacy content, and all the standards like SNOMED, CT, ICD 11, LOINIC, IRMA, DICOM, HL7, FHIR, it has to be followed. And if it's a hardware standard, yes, very, very important is biocompatibility standard, because the first thing is you are touching a material. That material should be biocompatible, for which you have to say that, yes, I'm in compliance with ISO 10993 and quality management standard ISO 9001, environmental friendly standard ISO 14001, information safety standard the IEC 27001 in the research level. Then coming at the planning phase and design and development, general standards, as I told you, IEC 6601, 6601 XX, pseudo collateral standards, SDLP for software IEC 62304, then usability IEC 62366, critical standard IEC 6600864, if battery is operated, particular standards, IT standards, audio standards. Then if you want to manufacture, till now we have not taken care of it. Till this audio standards is only inside the lab. It's a proof of concept. You're not gone out. You have not gone for CIDASCO validation processes. If at all you want to take your your device to the market, then CIDASCO has to give approve. Then what the first question CIDASCO will ask is whether your device is manufactured in a facility which is certified by ICMED Plus. So ICMED 13483 is a manufacturing facility certification. Then again, the risk management ISO 1400, management standard 14971 risk standard, occupational and safety standard where the industry is available, electronic manufacturing standard 14001, functional safety standard, process safety standard, and finally, how do you dispose your e-waste? You have a lot of, pen drives, computers, whatnot, hundreds of things are there, your mobile phone, they're all e-waste. How do you dispose them? And when you design a gadget, when you design a software, you have to put it inside a computer. Understand? So naturally, even if you are from you write a software, it has to get into some hardware. Then how do you dispose that hardware? What kind of hardware you will choose? What kind of design parameters it goes inside? What kind of environment friendly is your laptop? And then how do you dispose it? All this will come under R2 requirements. And then your building codes, fire and life safety. I think these are the very many things that you have to keep in your mind when you're working in the field of health informatics, public health informatics. SNOMED, as I told, is a standard for clinical. This is a systemized nomenclature for medicine. So systemized nomenclature for medicine. Okay, that is a SNOMED. Then eSanjeevani, yeah, the recent, thanks to Government of India, it has really come out very well. They are really taking it very seriously. National Informatics Center and CDAC, they are working day and night to propagate this idea of medical informatics and health informatics. eSanjeevani is nothing but a telemedicine network, and it's ABDM company. And I mean, if you want to be ADBM compliant, yes, you have to go for SNOMED IT. So all this comes in level 1. Next is storage and retrieval. In storage and retrieval, you have DICOM, LOINIC data, big data analytics, cloud computing, data mining, data storage. All these things will come in because you are storing and retrieving. You need physical devices like magnetic drum, magnetic storage devices, optical storage, flash memory, because there you are storing. That's why I'm just giving to you. These are some of the examples for storage medium devices, and you are storing in the form of a file. Then the question comes, what is the extension of the file? Is it a doc file, docs file, or RTF, text, PPT, CV, FLV, MP4, GIF, JPEG, PNG, HTML, CSS, EXE, DICOM, etc., etc. You should have an idea of how things are being stored. What are the formats? What is the header? What's the need for the header? So on, so on, so forth. Then if it's a biosignal format, how do you store ECG? How do you store PCG? How do you store EMG? How do you store, image? So you have to have some idea about all these things. And also you should have an idea about how much memory is required. If you are storing a MRI, 131 KB. If you are storing a CT scan, yes, 524 KB. If you are storing a color Doppler, what is the memory requirement? If you are storing a digital mammography, what is the requirement? Unless you have this idea, whether to compress it or not compress it will be a question. So electronic patient record, interoperable patient record, interoperability, semantic interoperability, syntactic. You're all computer science people. I not tell you. You are very much familiar and you know the seriousness of semantic interoperability, syntactic interoperability, levels of operability. You can see foundation. I mean, you can see foundational operability, structural, semantic, and organizational interoperability. So your program, your health, whatever healthcare informatics program you're developing for medical informatics, bioinformatics, clinical informatics, consumer informatics, imaging informatics, whatever be the field, they have to be interoperable. They have to be semantically interoperable. They have to be syntactically interoperable. Okay, their structure, format, everything has to go through a particular standard. So this is what is expected here. And it has to undergo HL7, FIHR. So all these things are there. IRMA is a wonderful area. Kindly go through the literature. I'm only introducing things and you'll learn a lot of things. There are subsequently 30 lectures. And if they are not dealt in detail, I think you are capable of going through the net. But just take the words, that's all. IRMA, data is available. I think it has come from one of the universities from Germany. Loinig is nothing but logical observation identifier names. All the laboratories, I mean, the clinical laboratories, pathological laboratories in India has agreed ABDM based because Loinig, they follow the Loinig standard. There's a standard how to store all your clinically significant data from the lab. And finally, how should be a report? Finally, how do you want to display your report? You can see this is my name. And you can see all my images taken on a particular day. Here you have dates. You click any date, all imaging modalities has to come. All my ECG, PCG has to come. All my prior data has to come. And the report has to come. Diagnosis report has to come. The therapeutic report has to come. Surgery has to come. Everything will be on a single page. What a beautiful reporting you have to generate. This itself is a job of hundreds of people. A perfect reporting format has to be done. So IoT based point of care, real time vital. So when you are online picking up signals, it has to be continuously. See, during a telemedicine telemedical consultancy, doctor and patient will be on video. Both of them will be seeing each other, and the doctor will also will see this report, which will contain all your data, which is online coming from IOMT. Also, will have access to the servers which is storing, which has already stored your imaging modality data, ECG, etc., etc. So in telemedicine, this will be a very handy. And only one problem I am raising, I'm red flagging is that unless that all our data is stored in a centralized database, this is not possible. So that's where we have to work. So FHIR, so slowly HL7 is giving way to FHIR. Yeah, no doubt the last 20 years, HL7 has been ruling the world. But today, people have, even the HL7 is from a consortium of people. They have themselves developed it, but they have agreed that, there's a limitation for HL7. So they are slowly moving towards FHIR. So they have to REST and messages. So these are certain protocols, FHIR protocols. Again, these FHIR protocols are developed by HL7, same community. And this HL, it is ABDM, which the ABDM, you can see ABDM is Government of India body. They insist that, they say that all your software programs written in healthcare area has to really take up only FHIR. That is the reason why our CDAC and MIC, whenever they are developing e-health services and programs, they adhere to FHIR. Coming to data, I told you, no, the data is of the order of exabytes. This is the biggest area in healthcare. See, exabytes. 985 exabytes by 2020. So what is the exabyte? 1 billion gigabyte is 1 exabyte. 1 billion gigabyte is 1 exabyte. And what is needed? Thousands of exabytes are needed. Because just imagine 750 crore people, if each has 5 IoT devices with him, 750 crore into 5, see mind-boggling data coming to you. If not simultaneously, at least 20% of is coming to you, or 10% of is coming to you. So 758 crores, 10% is 800 crores, 10% is 80 crores. 80 crores into 5 IoT devices, which means 40 crore IoT devices. So data has to come from 40 crore IoT devices for your analysis. So big data analytics, blockchain, all the beautiful words that is buzzwords that you are using today has to be understood. So this slide I have put just because to show that the amount of data to be handled in healthcare business, health informatics is completely huge. I need not tell you, my dear friends, all these things you know, 6 phase big data, healthcare support research, advantages of big data. You are better than me. There are 4 types of healthcare data analytics, which is descriptive, prescriptive, predictive, discovery. Yes. 5 types of healthcare data analytics in healthcare that can be used is AI, cloud computing, blockchain, health information exchanges, machine learning. And then 6 real-world applications are nothing but conducting early disease detection, improving documentation, managing financial resources, etc. These are some applications of big data. And this is the big data analytics healthcare. Medical claims, insurance claim, mobile data, non-retail, EHR, provider software, patient registries, etc., etc. So these are all the advantages of big data analytics. So that is level 2. Now coming to level 3 is processing and automation. Madam, you can just stop me with at what time you can stop, madam? 7:30, am I correct? Sachin,
Yes, sir.
Shelly,
Yes,
madam?
sir.
How much time
Yes,
we have
sir.
now?
Yes, sir.
Kindly just inform me, remind me at that time I will stop
So
it.
7:30, sir. 7:30 you can stop.
Yeah. Because I don't have, kindly just remind me, madam.
Oh, sure, Professor. So we make it.
Yeah. What is the time now?
7:15.
Good, another 15 minutes. Thank you.
Yes.
Yeah. So third level is processing and automation, biosignal processing, medical imaging, then algorithms, statistical, morphological, everything will come down. Yeah, just a glimpse of these things is data generated, data stored, data processed, and actionable data, insights. All these things will. Then cloud computing, SaaS, PaaS, and IaaS, which is infrastructure as a service. All these things is part of this health informatics. Then healthcare cloud will be generated, where the data will come from doctor, family, authority, physical activity, wireless, and so on and so forth. And diverse telemedical applications are possible because of this healthcare cloud computing, assisted by big data. This is a sample slide which shows what is signal processing. Pick up a data and this through the sensor, through the isolation amplifier, filtering, analog digital converter, signal processing, and signal post-processing, and clinical diagnosis. Then biomedical signal processing means pre-processing, time domain analysis, frequency domain analysis, classification, non-linear, multivariate, etc., etc. Even when you come to medical imaging, yes, you have a lot of visualization, analysis, medical vision, or computer vision. So that comes under medical analysis. If you go to feature extraction, because what you always talk about neural networks, when you all talk about neural network, you say what kind of features you are extracting, be it a signal or an image, 2-dimensional or 3-dimensional signal. Shape-based features like area, perimeter, circularity, irregularity, and so this is very important in analyzing red blood corpuscles, RBCs, WBCs, and the abnormalities in RBC. We really take up shape-based features, intensity-based features in mean, variance, standard deviation, skewness, etc., etc. Texture-based features like contrast, correlation, entropy. So these are all feature extraction techniques. The features which will be fed into the artificial neural networks. The next is the decision making and diagnosis. So for decision making diagnosis, a very good knowledge in pattern recognition basics. You have to study what is pattern recognition, what are neural networks, what is how do you take a decision, and what are the input nodes, hidden nodes, output nodes, what is the relation between them, and how do you reduce the dimensionality. All these things will come. Neural networks, fuzzy logic, neurofuzzy, artificial intelligence, machine learning, deep learning. All knowledge is required if you really want to work in the area of decision making and diagnosis. Then therapy and control. You can see therapy and control needs a very good knowledge in artificial intelligence, machine learning, deep learning. Okay, machine learning is nothing but input, pre-processing, feature extraction, feature selection, classification, and output. And here, intervention from human beings more, whereas in deep learning, intervention is less. So deep learning can be thought as input, feature engineering plus classification and output, whereas deep learning is split into various processes where the human intervention is more. So healthcare needs all these things: mobile health, artificial intelligence, big data, IoTs, 5G, robotics, wearables, 3D imaging, artificial. You have virtual reality, augmented reality. Then you have mixed reality. You have extended reality, and today you have digital reality. Okay, we started with the virtual reality, and next it came with augmented reality. Augmented, from there it became mixed reality. From mixed reality, it has come to, extended reality. After extended reality, it has come to digital reality today, and I don't know where it will go. So then you have 3D printing, biosensors. This is what I was telling: mixed reality, tissue engineering, bioprinting center. All these things, you have to have a good mastery over this so that you can work in health informatics here, research and modeling. Yes, everything starts with a model. Mathematics is fundamental. So representation of the real world is a model, and operation on this model is called a simulation. These are all the things that simulation helps us to understand the real insights into your system. Yeah, this is a model. You can simulate on it. Is the explanation to understand, and the advantage of these simulation models is that you can learn. It's actively individual can learn at his own pace. Just like when you look at your home, plumber's view of the home is different. Architect view of your home is different. Renter's view is different. Interior designer view is different. Tax collector's view is different. Carpenter's view is different. But the landlord view is different. And if it is my home, I will have all the views of other people. Okay, that's a consolidated. So multiple views for individuals, but for a person who wants it, it will be a complete comprehensive view. So respiratory system, digestive system, etc. And when you look at a child, I look at the child as a biological model, mathematical model, electrical model, biochemical model. You just imagine, for example, you take a respiratory system. In the respiratory system, how biologically it is represented, metaphysically it is represented, electrically respiratory system, biochemical. What is the biochemical model of a respiratory system? What is the graphical model of a respiratory system? Mechanical model of a respiratory system? Mathematical model of a respiratory system? Yes, that is called model. So human body can be thought as a chemical model, physical model, metaphysical, mechanical, mathematical, electrical, graphical, spiritual, and geometrical model. Metaphysical model is nothing but a combination of the 5 elements of the nature: space, earth, water, fire, and air. Yes, physical, metaphysical model. And virtual reality says that, yes, you can do wonderful virtual reality modeling using geometric model, kinetic model, physical model, and behavioral model. And then next verse, see, I started with the health informatics definition. In health informatics, medical informatics is one definition. In medical informatics, there are 6 layers. All those things we have seen. The next definition is clinical informatics. Clinical informatics is again nothing but clinical care, information technology, and health system. Nursing informatics is a combination of computer science, IT in the field of nursing to assist the management processing of nursing data. Nursing informatics, the definition is this. And what is the job of a nursing informatics specialist? Yeah, clinical, and he has to do all these jobs. Our duties, our jobs, and roles and tasks are very well defined. So the nursing informatist has this job to do. And we go for evidence-based engineering, medical imaging informatics, consumer informatics. We are all consumers of medical data. And there is a standard also for this. So consumer health informatics is a branch of medical informatics. Then, yes, you have consumer informatics, the definition, and so on and so forth. You can see that healthcare, inside which you have clinical informatics. Clinical informatics is a combination of medical, nursing, laboratory informatics, and consumer informatics. All this is called health informatics. Then public health informatics, because finally government wants to survey all the 140 crore people. What is happening where? In which corner of the India, what is happening? You have to survey the whole India, correct? If suppose you might have, we have undergone COVID. So that's a total surveillance. That is called public health informatics. So this offshoot of health informatics. So health informatics is a comprehensive umbrella which accommodates all these informatics. Elements of health and planning, system design, data collection, data management, etc. So prevention. Fundamentally, public health talks about only prevention of people. I mean, even you have disaster mitigation and management, epidemiology, public surveillance. These are very important. So till now, I have talked about the health informatics. The impact of this health informatics will be like this. accessibility, availability, affordability will be the impact of health. So if you do all this, whatever I said, I think every citizen of the world, every citizen of India will have access to wonderful fruits of the medical informatics, health informatics, availability, accessibility, availability, and affordability. And you can see, shifting from, that is very, very important. We are slowly shifting from hospital-centric to patient-centric. And we'll have no walls. We'll have virtual hospitals tomorrow. Physically, there won't be any walls. So that's the concept. See, facility will come to you. This is called what is called patient-centric, consumer-centric healthcare. People will visit your home. They will come. They will give all the treatment and they will move. Things will come to you. And we are moving from the term cure to well-being. That is the important thing. Cure is only curative maintenance. What we need is preventive maintenance. So with health informatics, my dear friends, please listen, lend me your ears for a minute. All what I say about health informatics is for prevention, which is very important. We have diabetes. Diabetes, the capital of diabetes is India. I think we should erase that. What we had a wonderful yogic culture. We had a wonderful system of health. We focused on prevention, not on curative medicine. Therefore, I think health informatics, you do something that you have to move from cure to prevention. So cure, care, and well-being will be the objective of health informatics. You can see here, 1935, hospital was like this, but the today hospital is something beautiful. You can see the wards. Now it's very beautiful, like 5-star hotel. Operating theater of 1935, 2005, unimaginably changed, but the records, medical records are still same. Unfortunately, in India, only 2% of the medical records are digitized, whereas 95% of the medical records are digitized in America, USA, and many advanced countries. We are nowhere. Where is 2%? Where is 99%? I think we have to do something. See? Historical barriers, financial barriers, cultural barriers, technical barriers, regulatory barriers, legal barriers. These are the things which comes in the way of adopting e-health. Transforming door and patient relations, the dose of technology. E-health stands for, E stands for efficiency, enhancing quality, evidence, empowerment, encouragement, education, enabling, extending ethics and equity. And we are living in a e-society, therefore we cannot avoid health informatics and many more. Okay, you can see. After all, you can ask me, why sir medical informatics? Why sir? See, things are changing. Everybody is now possessing a mobile phone. Number of devices has improved. IoT has improved. Data is increasing. Then you can see the growth. Extraordinary 25% growth is coming. You can see in terms of dollars and billions of dollars are invested. And mHealth is taken up. 97,000 mHealth applications are, mHealth apps are there currently. I think with all these things, I need not say that, yes, this is needed. So finally, first is health informatics, its impact. Now, what is the way forward? Way forward is quite simple. Yes, I will adopt all the standards and global standards are there. See, there are 11 global standards and our National Health Mission and ABBA has adopted this, in fact. So this, whatever is said by WHO is in letter and spirit, adopted by Government of India. So these are the National Digital Health Mission. All whatever is said there, it is available here. The state of art, the digital health. Our Honorable Prime Minister and all our health ministry are working for digital health. I think we are right track. So health informatics has to come very fast, get adopted. See, digital health. See, 15.7 doesn't mean, what I would like to say is India is nowhere backward in terms of digital transactions. See, every year there are 15.7 lakh crore digital transactions happening in India. But what is not happening is it is not happening in healthcare. That is the unfortunate thing. So we are way forward in digital transactions financially, but in the area of healthcare, we are very poor. That is where we have to improve. And ABBA unique ID is there, accessibility, availability, and affordability. And unfortunately, the data, the electronic health record for all of them is not there. I think a day has to come. We all should work. So National Health Mission has been formed. This is a way forward. Its aim is to see that ensure health lives. Yeah.
Professor, in case you would like to stop, we can stop here and then we can ask some questions and then later on you can take some break and then we can resume the session.
Sure.
Yeah,
I'll
please.
stop here. Yeah.
Yeah. Now, I would
Yes.
like to ask from the participants if there is any question, you can ask to Professor Muttan and then sir will take a little break and then we'll resume the session.
Thank you.
Any questions from the participants?
Hello, good evening, sir.
Good evening,
sir.
Yeah.
Sir,
Sir,
myself,
this
Dr.
is
Tusakam
Dr.
Sab-
Bharani Srinivasan from Pondicherry, sir.
Yeah. Good evening.
Yeah,
Sir,
sir.
my question
Sir,
is that
you said all the health, all the health informatics related, sir. Now, even in India, having a EHR is more feminine. Many hospitals are using that alone.
Correct.
Shall we synchronize all those things, sir? All the hospitals in India have it because the government policy must be needed for this. I hope that because if Apollo means they will have their own data, they cannot be shared with other hospitals. If the patient go for other hospital, they need to be do all the test and the diagnosis process again and again. Shall if synchronize all this diagnostic data that help the patient to reduce the cost? It is the possibility, sir.
Perfectly. I think you understood my lecture.
Yes, sir.
That is what is needed, my dear friend. And the problem with see, understand, I have been in e-governance, a lot of automation process. The problem with automation is a top-down approach. It's not bottom-top approach.
Yes, sir.
Top-down approach means the number one has to be digital literate, which means if the what we imagine here, what we like to have is 140 crore EHR, all standardized data, whether you go to Apollo or just like our mobile phone, correct? Whether you are with
Yes,
Tata, Birla, whatever, mobile phone number doesn't change. Am I correct?
Yes, sir. Because all the patient must have UHID.
Correct.
Unique hospital ID for the
slowly they're coming up.
patient.
See, the ABBA number has come, they have created, but unfortunately, what is happening is the data is not stored in a centralized database. What I imagine is for your kind info, I'll take just 2 minutes, they can go for a. See, we have to have a centralized servers. Okay. Wherever I go, I go to imaging center, pathological center, clinical testing laboratory. I go to your doctor. Wherever I go, the data has to go to only one point where I'm connected.
Yes, sir.
If such a facility, that is for 140 crore people, there should be a third-party administrator. There should be servers. So wherever I go across the world, my data has to be stored in only one place. So accessibility becomes easier. For this, currently the problem they say is privacy and security. I cannot share with the data. No, it is wrong. Because what Government of India has said is, if the patient gives the consent, let me repeat, if the patient gives the consent, the duty bound, the government is duty bound to share the data of your doctor, but the maturity has not yet come. The medical fraternity is worked on only with stating that, yes, it's a privacy to privacy. How long you can say that? See, I'm the patient. I'm giving all my money. It's my record. You can share with others. Then they have to give. That has to happen. That has to happen.
Thank you, sir. Thank you, sir. Your explanation is very nice. Thank you for the organizer giving me this chance to ask questions.
No, we have to see the biggest. We had to sit with the maternity. I mean, the medical fraternity people. See, they're. I think I can understand the problem. They feel that the patient data is very, very important, but that's not correct. Because see, let me tell you, it's very organizing, heartbreaking to see that not even a single image I get for my research. But every year, 12 lakh of imaging data is procured by radiology in Tamil Nadu. 12 lakh, that it is going. If you give to me, I can produce wonderful results. It will go to the benefit of my people. Just by telling that privacy, we are postponing everything. I think a day has to come. All of us should sit together. And yes, privacy, security of a patient has to be protected. No doubt about it. There is a law for that. However, you can remove the name. There are some procedures that has to be done.
Yes, sir. Yes, sir.
Yeah.
Thank you, sir.
Yeah, you're welcome.
Participants, please, other queries we can put, sir. Now the time is 7:30. 7:40 we can start.
Okay, can we have a break now?
Break. Yes, sir. Yes, Professor. Yes, Professor.
Sure, we'll meet again. Thank you.
Thank you, Professor. Thank you. Participants.